Alrighty, folks, we are going to be looking at 13.3 and we're going to break that down again because of distance learning. So this is just going to be day one. We're going to be talking about something called reference angles. And as it says here, a reference angle, theta prime is just the way that we notate that we're asking for a reference angle that's related to the original angle theta. For a given angle is an acute angle. So there's kind of three rules for reference angles. One of them is that they're always positive, so you will never give a negative answer to a reference angle question. Secondly, they're acute, which means that they have to be between 0 and 90, so that theta prime will always be between 0 and 90 degrees. And we will be working with radians, so 90 degrees is the same as pi halves radians. So it's always going to be something smaller than that. Okay, and so then it's talking about it's formed by the terminal side of the given angle in the x-axis. So the third rule is basically that it's the closest way to the x-axis. So that's really improper grammar, but you get it. So there's three things. You draw your original angle theta, and then you find like what is the closest way to get to the x-axis? What's my shortest route? And because it's the shortest route, it has to be less than 90. And because you're just asking how far away am I from the x-axis, it's got to be a positive number. So you're not going to have a negative value. Okay, so if I had something in quadrant one, let's say I had an angle right here, and so that was my original theta, then in that particular case, the reference angle is going to be the same thing. So say that this was a 50-degree angle. When I draw it, the closest way to get to the x-axis is to go right back down here. And so in this case, the theta prime is going to equal the same thing. Now, I wouldn't try to like memorize rules for each quadrant because that gets really complicated. The easiest way to do this is sketch the original and then just find the theta prime, the reference angle, because sometimes you're going to have to add or sometimes subtract or whatever you're going to be, sometimes subtracting from 360 or 180. And so it's just easier to draw that out and then see what you've got. So let's say I'm in quadrant one. So let's say maybe I'm at 120 degrees as an example. That would put me into quadrant one. So that means that this is my original theta, but that can't be my reference angle because it's greater than 90. So instead, this would be my reference angle. That's the closest way to get to the x-axis. Since this is 180, I would be taking away my theta. So to find my theta prime or reference angle, I would do 180 minus my original angle. So in this case, if I had started with a theta that was 120, then my reference angle, my theta prime, would be a 60. But again, don't try to memorize these, just sketch it out and then take a look at it and see how it looks. To get into quadrant three, I have to go all the way around here. So then that theta is going to be into quadrant three. So kind of think about that. Like maybe imagine that you used a 200-degree angle. You passed 180, but you'd be looking for this chunk right here as a reference angle. So in here is going to be my reference angle. All right, well, in this case, I'm thinking, how far have I gone past 180? So I'm really still finding the difference between 180 and that other value that I used. But in this case, I'd be taking the absolute value and saying, hey, the difference between these in this example is 20. And so that's going to end up being my reference angle. So in my example, the reference angle would be 20 degrees. But in general, you're finding the difference between the 180 and the theta, and then making sure that it's positive. To get into quadrant four, you're going all the way around here and stopping over here someplace. So then that makes this your theta, and it makes this little acute angle your theta prime or reference angle. So again, just think of an example. Say that I went 300 degrees. Okay, well, if I went 300 degrees, I'd be over here, and I'm actually closer to the 360-degree end of my circle. And so I'm going to look and say, hey, what is the difference between the 360 and where I stopped? And again, it has to be a positive value. So in this case, if I used a 300, then my theta prime or reference angle would be a 60. So again, don't try to memorize these rules, but draw yourself a sketch and then figure out where you're going. So as we talked about, a reference angle is always positive, and it's always between 0 and 90 degrees, but we're going to be working with pi halves. And on the IXL for this, you do have to go to 10, meaning 100 SMART score if you want full credit. And that is because up into the 80s, you only have angles that are in degrees. It's going to be super fast. It's just going to be quick drawing a sketch and maybe doing some subtraction. But you want to practice getting into the radians because those are the ones that can be a little bit trickier because it's new to us and that language of radians isn't quite as familiar. So let's actually go through these and do the degree ones first. So 110, draw yourself a sketch. You know this is 90, you know this is 180, so you know you have to go a little bit past 90 degrees in order to draw your 110 degree angle. So this is my 110 degree angle, but this would have to be my reference angle over here because it has to be, again, that shortest way to get back to the x-axis. So if this is 110 and this is 180, the difference between those and the space between them is going to be 70 degrees, which is going to be my reference angle. Now, negatives always make you think harder, but if you're going negative, you're going to pass this, but you're not going to go as far as the 180. So I'm going to come by here, and then I'm going to stop in this quadrant. If this is my angle, this is my negative 130, then I'm still looking at this over here as my reference angle, saying how far away am I? So if I've traveled 130 degrees in a negative direction, how far am I from the 180 mark? And so in that case, I would be 50 degrees away from the 180. So my reference angle is going to be 50 degrees as well. All right, let's jump ahead to the next one that's in radians. 315, keep in mind that this is 90, 180, 270, and then all the way around is 360. So 315 is going to put me over here. That's my actual angle of 315. This would be my reference angle then. That's my closest way back to the x. You're always trying to get to the x-axis, not the y. And so in this case, if I'm trying to get back to the x-axis, it would be the difference between these two, between my 360 and my 315. And so in this case, my theta prime or my reference angle is going to be a 45 degree angle. You're 45 degrees away from the x-axis. Okay. And then we've got one more that's in degrees, and it's a negative 50. So I'd head down this way, but I'm not going to go as far as negative 90. I'm only going to go down to negative 50. And so at that point, I'm how many degrees away? Well, in this case, that is the shortest way back. So I would have to say that my reference angle is positive 50 because I'm 50 degrees away from the x-axis if I've traveled negative 50 degrees from the start point. So that's going to be the degrees, and that's going to be the majority of your IXL. Until you get towards the end, you're really not going to see the radians, but they are the trickier ones. So let's go back and revisit those. This goes back to what I talked about on a previous video on how do you graph these? Like, how do I know where the sketch is? So again, I look at the bottom number. This side will always, since this is a 1 pi, I would put 3 over 3, which would reduce to 1. And then I would write 6 pi over 3 on this end because that would reduce to 2 pi, which is all the way around. So this is also the 0. So that makes the top 1.5 pi over 3 because that's halfway between 0 and 3. And then if you wanted to kind of count around, this would be 4.5 because that's halfway between 3 and 6. So when I go to draw 5, I know that it's just a smidge past here. And then I look at it this way. I traveled 5 pi thirds. Fastest way back, according to my sketch, is right here. So if I'm at 5 pi thirds trying to get to 6 pi thirds, the difference between them, and therefore my reference angle, is going to be 1 pi over 3. So the sketch is just important to figure out where I am and which end I'm closest to. So now we're going negative and we have pi's, so that's going to be tricky. So if I'm going negative and I have a 12 on the bottom, that would make this side negative 12 over 12. And then it would make this side, if I get all the way around, negative 24 pi over 12. So 7, this is also 0. Halfway to 12 would be a negative 6 down here. So negative 7 is going to be just a hair past that. So this is my original theta of 7, negative 7 pi over 12. So now my sketch tells me that the closest way to the x-axis is to go to this end, which is negative 12 pi over 12. So the difference between this 7 pi over 12 and this 12 pi over 12 is going to be 5. And so I am 5 pi twelfths away. So that is my reference angle. So just putting a lot of concepts together. So let's take a look down here at negative 2 pi over 3. So again, it's negative. I have a 3 on the bottom, so this would be negative 3 pi over 3. All the way around would be 6, but it's also 0. If I'm going to 3 pi here, halfway would be 1.5. So if I'm trying to get to negative 2, I have to pass that by. It's important to know that I'm on this side, so that tells me this will be my closest way to get to the x. So I'm looking for the space between a negative 2 pi thirds and a negative 3 pi thirds. Doesn't matter if it's positive or negative, the space between 2 pi thirds and 3 pi thirds is going to be 1 pi third for my reference angle. All right, and last but not least, 5 pi over 6. So that would make this a 6 pi over 6 and a 12 pi over 6. Halfway to 6 would be a 3. So that's telling me that to get to 5 pi 6, I'm going to pass by the 3 and head over here. So I'm going to make it this far. So my reference angle is going to be that little acute angle between where I ended and where the x-axis is, whatever's closest. So I'm looking again, I went 5 pi 6. This is 6 pi over 6. So the space between them, and therefore my reference angle, is going to be pi over 6. All right, so we are done with that. Use the video, go back and kind of walk through it as you do your IXL. Most of the IXL should be quick, but just take your time on your subtraction and your thinking. A sketch is super helpful. You'll get to your goal faster if you don't make any mistakes. So it'd be wise to just have a piece of scratch paper where you can draw out the pictures, and that way you'll know which end are you closest to and how should you get there. Have a great day, you guys. It's nice outside, so get out there, and I will see you later. Bye.